Hi everyone. Today let's look at the problem largest subarray with zero sum. This is a problem from Geeks for Geeks. Given an array containing both positive and negative integers, the task is to compute the length of the largest subarray that has a sum of 0. This is a very interesting problem, so I thought let's discuss this. The idea is to find the largest subarray that gives a sum which is equal to 0. So this is only possible if you have both positive and negative numbers. The brute force approach is to try all the different combinations, that is start with 15 and see whether any of these subarrays containing 15 will be able to give the total sum as 0. Like that we can try starting from -2 and so on. This will take a time complexity of order of n squared. Can we do better? There is one approach, so let me talk through the approach here and give you the intuition of the problem. This will need two things. One is the prefix sum, so we will keep calculating the prefix sum from left to right, and the second part is we will have a hash map with key as the prefix sum and index in which this prefix sum is obtained. And there is a small catch here. You will always store the first index in which that prefix sum is obtained. I can explain further and then this will become very clear. Now if I take, so let's put this as our prefix map and let's take the below example here. So we have a prefix map and basically a prefix sum that we calculate as we move forward. It will start with 15, then this will become 13. So as we go, we will also store this in a map. This will have 0. So the index 0 will contain this data. Then the next prefix sum is 13. So this will be 13, 1, and then this will become 15. So if you see here, this can only get back to 15 if the sum after this point is 0. When we see 15, we will check was there any index where already this sum of 15 was obtained. This will be a match. So if I take the current index if it is I minus the index in the prefix map where the same value was there, that will give me the current length of the subarray sum where the total is equal to 0. Max length is equal to, so you will get 2 minus 0, so which is 2. Now let's keep moving forward. So we will not store this value, instead we will this index value, instead only the first index. Then next we'll take so minus 8, so that will be 7. So this will become 7, 3. Then we will have 8. And if you see, again we will get 15. So what this would mean is this total sum is also equal to 0. That's the only way this will match. Now the max sum will be max of 2, that is 7 minus 0. So that means this will become 7. Because you can see, right, this much together is summing to 0. That is the only reason why we are getting 15 again in this particular index. Sorry, this index was 5, my bad. So this is 5 minus 0. The answer will be 5 here. Since 15 is already there, we will not add it. The next will be 25, 6, and finally the next one will be, I think, 48. So this is one particular use case. Now the other use cases that is not covered here is the actual prefix sum from start could become 0. For that I have taken another example. We will take the same logic. So we'll start with minus 31 here. This will become 31, 0. Then this will be minus 31 minus 48, that is 79, minus 79. Then next will be minus 169. Then we will add 54 here, so that will be minus 115. Then next we will have minus 95, and finally this will be plus 95. So here you will get actually a sum 0. This means this entire array is also 0. So this is a use case where the prefix sum itself becomes 0. So we will have to consider that case also. So you can consider a subarray starting from 0 to this point. So that's a special case that we will have to handle. So that means the max length will be I plus 1 here. So that is this would have been 6. Then we will have 6 comma 6, this will become minus 80, this will be minus 58, 8. This is what we'll end up with. So the max length will be 6. Before we code, let's also look at the time complexity. So this will be order of n, because we'll just iterate through the array once. Space complexity will be order of n, because we will need a prefix map here which will be of order of n. Now let's just code this up. So we will have an unordered map which will have int comma int, and it is just basically your prefix map explained above, and then we need a variable to store the prefix sum, and of course the final data, which is the maximum length. We will just go through for auto I is equal to 0 to array dot size. So go through the elements of array from left to right. I think we have to take care of a corner case where one element can also be 0. So we'll find the prefix sum. Let's check the case. Check if total prefix sum equal to 0. Max length is equal to bi plus 1, and we will also put prefix map prefix sum equal to I. Now the other case is we will try to find if in the map there is an entry. If it is there, then our max length will be equal to max of max length comma I minus prefix map of prefix sum. I hope this is clear. Okay, we are talking about this particular case. For example, when we came to this 15 or when we came to this 15, we just took the I minus 0, so that gave us the total length. Now the next case is we don't need to add this value into this prefix map because it's already there. Then what we'll do is else we will just add prefix map of prefix sum equal to I. Yeah, we'll just store it. Return the max length. I think this should cover all the cases. I is equal to 0. Then we calculated the prefix sum. Check if the total prefix sum is 0. Then we also take whether there is already an entry with the same prefix sum. And finally, we just update the prefix map to prefix sum equal to I. Now let's just run this thing. Okay. Okay, so this looks good. Hope this is clear. Thanks everyone. Have a good one.